Hi, I'm Thomas Poon, and I designed a ping pong launcher. Now, the reason why I picked this project was because I enjoy playing ping pong a lot, but my friends aren't always there to play with me. I have tried some other solutions, such as playing against the wall, or the folded up side of the table. But those don't really give me a real feel for playing against a real person. Now, I started this project with three constraints. The first being that the launcher must always shoot onto the player's side of the table. The second being that the launcher must shoot different types of balls, for example, their speed, their angle, and their location on the table. And third, the launcher must give the player enough time to return the previously shot ball before shooting the next. Now that I've explained this project, I'm going to show you the parts to it. So here we have the part of the launcher that actually shoots out the balls. Now, this is done with these two wheels. The gap is the perfect size for the balls to fit in and then be shot out the other side. Now, when I first started this project, I actually had two motors spinning these two wheels. But I was unable to set them up in a way that would have the wheels spinning in opposite directions, so I changed up the design. I went on to setting up a gear train that only required one motor. Now, this motor is in charge of spinning all of these gears and thus the wheels. This actually proved to be more efficient than using the two motors, because not only did it spin the wheels in opposite directions, but also in the same speed. Now, the gear train we have on top is set up in certain ratios to increase the speed of the wheels, thus shooting the balls further and faster. Now, when I first began testing out the launcher, I actually didn't have access to a coding program. Instead, I used this 3C power supply, and I set up a breadboard to supply the motor with energy. Now, what I found out later was that the Vex Cortex actually didn't supply enough volts for the motor to spin the wheels fast enough to launch the balls. And there we have it. That's the launcher. Now, here we have the base. I created the base to control the angle that the launcher is facing, thus the directions that the balls will be launched. Not only does the base change the vertical angle of the launcher, but it also changes the horizontal as well. This can be done with two separate servo motors. Now, here we have the vertical, and here we have the horizontal servo. I placed the horizontal servo on the axle of the vertical servo through these gears. As you can see, when the vertical servo moves, it changes the x-axis of the horizontal servo. Now, this is important because the launcher is actually set up on the horizontal servo, just like this. So, setting up the servos in this way allows the launcher to move both horizontally and vertically. Now, that is the base. So, here we have the container. Its sole purpose is to hold the balls. It's a piece of paper that I rolled up into a pipe, just the right size so the balls would fit in and roll down to the bottom without getting stuck. Now, I originally planned to use PVC, but my friend Brian convinced me to use paper instead because it's easier to manipulate, lighter weight, and cheaper. Now, the balls we just rolled down are in line to be fed through. Next in line, we got the feeder. It controls the rate at which the balls are pushed into the launcher. Brian helped me 3D print this feeder, which you can imagine as a triangular prism with concave sides. By having these concave sides, balls will fall in due to gravity and then roll out when there's an opening, as you can see. Now, the feeder is programmed to push out one ball at a time so that the player has some time to recover from the previous shot. And there you have it, the feeder. What I have typed into Robot C here is the code that controls the entire machine. Here we have the potentiometer that acts as a switch for the machine. When it is rotated to the on side, the program will begin. Now, Inside the program, I have coded that a random number from -25 to 25 and -20 to 20 is added to the vertical and horizontal servo settings, respectively. It also limits the largest and smallest numbers that the servos can be set to in order to ensure that the launcher does not shoot balls off the sides of the table. And when it is turned off, the launcher will stop shooting and recenter until it's turned on again. To allow the player to turn on and off the launcher as he pleases, I put the code into an endless while loop. And now that's all the parts to the launcher. Now here's the actual thing. So there you have it. That's my project. Now, of course, just like any other project, I faced a lot of obstacles. The first one I faced would be making the two wheels spin in opposite directions. Now, I didn't figure out till a little while that I could use a gear train on top of that to make both of them spin using only one motor. The second problem I faced was giving the launcher two-dimensional rotation. Now, I already had the idea of using two servo motors from the start, but I didn't know how I was going to connect the two so that it allowed this vertical and horizontal movement. Now, eventually, after trying a lot of different methods, I got the horizontal servo onto the axle of the vertical servo. And this allowed this two-dimensional rotation that you see in the video. And the biggest problem I faced was making a container that dropped every single ball out. Now, I tried a funnel and I tried a box, but both of these provided too much room and allowed the balls to block each other's path, clogging up the exit. Now, to fix this problem, I went back to my PVC idea. But instead of PVC, I used paper and rolled it up. Now, this worked just perfectly, and it ended up being my final decision for my container. Still, I don't feel like this project is complete. There's a lot of things I want to add and fix to it, like putting up a net so that the balls will be caught, so that the players don't have to go around collecting the balls after every game. Or making a system where the balls are fed back into the container so that the game can go non-stop until the player stops the program. Or even making the balls have different spin to add a little twist to the game. Now, one of the other things I'd like to fix about my launcher is the loud noise produced by the gear train when in operation. Now that I'm done building my machine, I'm glad to say that I fulfilled all three constraints that I set at the beginning of this project. Of course, there's a lot more that I want to add to this, but with the time constraints I was given, this is what I was able to do, and still, I'm very happy with the product that I made. Thank you.